we are continuing with another amazing duo. So I would like to present Miodrag Ivanovic and Vukovic from BOSCH. They will give us an insight how did their company adjust its daily operations in accordance with sudden and unpredictable changes. Let's welcome Miodrag and Naidan.
Okay, so we hear each other? Okay, good. Thank you. So good evening, good afternoon, ladies and gentlemen, dear friends. So this is going, first of all, thank you all for coming and for staying at this presentation. So this is going to be a, well, let's say, short presentation of 20 minutes or so, which will show our efforts in last 12 months, in which we involved sorry, so it's being like with the microphone. So this is going to be a short presentation about the work that my colleague Miodrag Ivanovic and myself performed in the last 12 months regarding estimation of arrival time in presence of uncertainty. So in the next 20 minutes or so, we are going to present you with a business use case. Why is it important for daily operations of a BOSCH as a power, especially for a BOSCH Power Tools division? Finally, we are going to show you the results, the model that we implemented, and above all, what actually the business guys think about it. So before we start, I would like to give you Miodrag Ivanovic, and he's going to present you the business case and all related to that, and I will take over with the model. So Miodrag, the stage is yours.
Thanks, Naidan. Hi everybody. Hi, my name is Miodrag, and as Naidan, I'm coming from the company Robert Bosch, and basically, beside this obvious physical similarity between us, what's funny between Naidan and me that we almost joined Bosch at the same time, and from the day one we are supporting the same division, basically Power Tools division, logistics department. So this supply chain topic is something which basically bonds us, except as I mentioned, physical similarity. So first things first, let's talk about the agenda. We will explain a little more in details what supply chain management is, what supply chain is, and what are the current challenges in supply chain worldwide. Of course, Bosch as a worldwide company has its impacts on these challenges, and we will tackle also this case a little more in details. But of course, the majority of the presentation will be regarding the IT solution which we developed, basically which mitigates these goods arrival challenges. So first things first, let's talk a little bit what supply chain management is. As you can see from this picture, basically it consists of two flows, material flow and information flow. And when we say supply chain, what does this mean basically in its core? It is the connected system of organizations, but also activities among them, then information they're sharing between each other. But also what's interesting is that this connected system is sourcing, producing, and delivering goods from the supplier to the end customer. And we are talking here about material flow. On the other side, you have something which is information flow, customer information, which is also important because we want to have more and more satisfied customers, so these surveys and other information. This supply chain system is quite complex. We are talking about worldwide system, which basically is heavily dependent on external influences. And by some reading, I think from 2013, basically almost 80% of all the goods worldwide is transferred by ships. We, as a huge international company, basically diversified our plants worldwide, and the division Naidan and myself are supporting, basically located a majority of its plants in Asia-Pacific region. So how this looks right now, this is a, let's say, global ship tracking in the November 2022. So you can see basically from this slide, thousands and thousands of ships are transferring goods on daily basis from one geolocation to another, from one part of the world to the other part of the world. This whole system basically worked quite fine until 2020, before our Corona arrived. There is a pattern which was well established in decades, but I don't want to go into details what happened with Corona. The borders were closed, the shores were closed, so it impacted quite heavily the whole thing. Right now, we still are not recovered from the problems regarding semiconductors, and in the upcoming years, we will also face these issues. Of course, Bosch is not an exception. We also suffered in the past years, but not just Corona basically caused the whole worldwide problem. Also, we have a Suez Canal blockage in 2021, famous Evergreen ship. Then basically in the spring 2022, you have something which is called China Zero COVID-19 policy. All those small dots represent ships waiting to be loaded near the shores of China. So you see, we are talking about huge worldwide problem. Of course, in 2022, we are having complex geopolitical situation with Russia and the Ukraine, which is jeopardizing not just ship traffic, but also air traffic, trains, and others. So in this whole mess, we at Bosch thought, okay, how can we deal with this problem? And what I'm very proud of is that we on Serbia location basically tackled this, or try to tackle this problem, because in our division, we face the situation, we don't know when the goods are arriving at Western Europe. Because, why Western Europe? Because in Western Europe, we have majority of our international distributive centers. And from there, we are delivering goods to our customers. So the question was, okay, what should we do? Because estimations are roughly wrong. So first things first, we, at 2021, contracted external data providers. We saw that basically information we are receiving for SAP, I will show you a little more in details what I mean, is not accurate. So we tracked our containers on daily basis regarding GPS coordinates. And we are doing still. Basically, we signed a contract with 2-3 data providers companies. And the idea is, through web services, we want to have this information on daily basis. From the day one, we saw the huge potential basically in this. And I'm also proud that we were one of the pioneers in the whole Bosch ecosystem regarding this, which basically brought us to much more accurate estimate time of arrival. Because this delivery time between, let's say, Asia Pacific and Western Europe become very, very huge problem for us. What also we saw as a huge potential and extend talks between two of us is basically how can we use, because we saw the potential that somehow we use this information in more extent. So we say, okay, but we have our product owner who was also familiar with us, and we saw the big business case and the benefit to mitigate this problem by creating machine learning algorithm which can calculate predicted time of arrival. Because with this information, we can respond to our customer much more accurately. The customer says, okay, I want to buy 10,000 drills when I'm receiving these goods. And the problem that in some occasions we could not respond to this. So you have customer unsatisfied, potential market loss. So the huge problem which generate additional costs in the whole disinflation time. Basically here, if we are talking about impacts, this is the current situation. This blue line is representing the information we are receiving from SAP. This gray line is the data we are receiving from our external data providers, which was the enabler for this machine learning algorithm. So you see a quite deviation between these two. And the idea was, okay, how can we put these two together? Because you see in December, SAP is giving almost 50% deviation compared to this gray line. Because for each and every material you're producing, you have something which is called the lead time. Lead time is measured in days, and basically it represents the number of days you need to produce something, pack something, transit something, and deliver. And SAP is not calculating those external influences. Basically, for each and every material, we have kind of a hard-coded number of days. And in December, for example, we said, OK, we, for example, have 3,000 containers coming in Hamburg. But in reality, we are having, for example, 1,500. So we booked a place, additional storage space, which is not used. So we have problem with plant management, but also with IDCs, International Distributive Centers, where we store our goods. So we are wasting money. But in January and February, we have a bigger problem because we are saying, hey, for example, you will have 2,000 containers. In reality, you receive 3,500. So you plan for 2,000, 3,500 come. What you did now, you don't have the space. So you need to do some ad hoc planning, which in these crazy times with inflation costs basically millions of euros. So this is why, let's say, we saw the huge potential, and this is what we worked in the previous year intensively on this topic. So for this is our business case. Ship routes from China to Western Europe. As I mentioned, almost 90% of our goods are coming from Asia-Pacific region. And based on these dots, the model was created. And how this works basically in details, I will now give my sibling opportunity to explain you a little more in details. Thank you.
Okay, so as Miodrag pointed out, so we are actually focusing on the factories, the plants where the majority of power tools parts are produced. So it's Asia Pacific, it's in China, it's in South Korea. And of course, we said it's like 80 or 90% of goods coming down. But wherever you actually want to make something, you need to go to Asia Pacific, you make it down there, and then afterwards you ship it by the ship, of course. You go to the Suez Channel, to the Mediterranean Sea, through Tangier, and so on to the Western Europe. In Western Europe, the Bosch uses the most important harbor, which is called the Hamburg one, right? The second one is the Bremen harbor, and the third one is the biggest port in Europe, which is, of course, the Rotterdam. So why is this, okay, so let's try. Why is this important? So first of all, you have your containers located on a ship, but first of all, you have a dock station where the Bosch actually pays for that ship to get there. If you miss your window, right, you need to pay for that, and afterwards you need to pay for additional window of discharging. So that is the big problem. And right now, nobody knows when the ship is going to come. So that is the reason why we actually approached to a data provider. And the data provider told us, okay, so we can provide you with this data. So basically, this is the data. Where is the data coming from? So we have a port of loading, so the start point of our journey, port of discharge, the end, the location of a ship, represented with the longitude and the latitude. We have the planned time of arrival. So remember this guy, we are going to talk about it, because this is our main contender afterwards. Date of port of loading, so where your journey actually starts. Current date, right, so the date of the snapshot. You have a shipping line, we have a vessel, and container ID. So bear in mind, on one vessel, we can have multiple containers. 1, 2, 3, 5, 7,000, whatever. So that is the point basically over here. The time window we actually have for the data is November 2021, daily snapshots up to the current date. And our data consists of, well, roughly 14 major shipping lines. Of course, we cannot provide the names, but you can easily find which are those. Somewhere more than 300 ships, 300, 350. And in this time interval, so starting November 2021, we identified 2,000 individual trips coming from Asia Pacific, that is from a majority from China, to Western Europe. So what does it mean, individual trip? So one ship, regardless of which one, goes from China, so from Shanghai, for example, to Hamburg. And that we say, okay, so that is the one trip. I promise you this is the most boring but most colorful representation we have, the slide we have over here. So for those of you more statistically inclined, so these are called the box plots. Those are not, who are not statistically inclined, we are just going to say that over here we are represented the distribution of respect with the shipping line and respect with the ship. So we just take, for example, for a shipping line, we take each trip made by one shipping line, starting from China to Western Europe, and then we gather all the data, regardless of a ship. So, and afterwards, so we do the same thing for one ship. So if you look over here, so for example, you can see that some of these shipping lines are a bit faster, right? So they come a bit faster to a rate, to a port of discharge, while some of those are not that fast. So just one thing, so bear in mind that in the data, we do not have information if the ship is going to, for example, be docked in Athens or in Rijeka, because that is something that happens frequently. So we only know the ship is going to go, the final destination of a ship is Hamburg, but it may go, for example, to Athens, wait for a day, and then that's why you have this lag over here. As for the ships, so you can see as well, so there is the great variety over here. Of course, 300 and more ships. So that's why it's important to study each and every ship and each and every route they are taking from China to Western Europe. So how did we model it? So starting from a port of loading, we are going to a port of discharge. Over here we have our ship in some time interval T, for example. We download the data, so the data we had over there. Some of the data are static and some are dynamic. The only dynamic data we have currently is the position of a ship. So two of us, being engineers and the boys, the first thing we went like, okay, how fast the ship is actually going, right? And you calculate the velocity of a velocity of a ship over 24 hours interval, over 48 hours, 70, and so on and so on. So that's one of those dynamic variables. The second one is how far you have traveled from your port of loading, for example, and then we take like the increment between two successive timestamps. So for basically the answer to a question, how much or how long does a ship on average travel for 24 hours? And then we get it in, of course, in the SQL database. You get your model, you get the forecast on the first horizon. So starting, for example, on Monday, we forecast where the ship, how long is it going to take from Tuesday onwards to get to your port. And then in the same moment, you provide for the Wednesday and for a Thursday. And then you just spin it up until it actually reaches the port. As a technology stack, so it's pretty easy. So we just used the XGBoost. Why? Because first of all, we got the tabular data. And when you get the tabular data, it's a really good data science, let's say, perspective or experience to try with the XGBoost or LightGBM just to set the bar. So you set the benchmark. They are going to be really good, right? But you set the bar, and then upon that bar, you build newer models. So basically, no better explanation why XGBoost except for that one. As a cross-validation one, so we developed both and based on Optuna, scikit-learn, and HyperOpt. Once again, no better explanation or no optimal explanation why we finally have chosen to use HyperOpt, except for myself being a bit more Bayesian biased. So because over here in HyperOpt, we can gather all the data, and then you have a distribution of your all hyperparameters, and historically you can see which hyperparameters are really, really important and which change, right? And you can disclose all the other hyperparameters which are just like a point, right? So there is not that much variety. And then you can easily just like switch to a grid search if you have that case. Training, cross-validation, and retraining, pre-processing is missing over here, is approximately like 30 minutes. So each day we get the data from a data provider. It's running on the Microsoft SQL server, so you got all the pre-processing you need. Finally, we get like in the Python, in the Jenkins server, we spin the model up, and after 30 minutes, you get your basically tables in the Microsoft SQL server once again, and finally, the report in the Power BI, which business guys can actually use. So over here, we can see what are the results we actually achieved. So firstly, we use something which is in econometrics called backtesting. So starting July 1st to October 31st, it's like 4 months, right, of data. So each day we added a new data point, spin up the model, so new training, I mean, new cross-validation, new pre-processing, new cross-validation, new training, you get your forecast. Then you add the data tomorrow, you go through a process once again, and so on and so on. So basically on the first horizon, so for your Python inclined, so 0 means actually 1 in Python, right? So this is the forecast on the first horizon, on the second horizon, and on the third horizon. So as you can see, we measured a lot of these statistical measures, but we took over here just mean absolute error, mean square error, and the bias. And bias, for example, tells us, okay, so when you are wrong, when you make a bad forecast, do you make that forecast in a plus sign or in the negative sign? So are you underestimating or overestimating? So over here on the first horizon, you can see that bias is like 0.8, which means like almost a 1 day we are in the positive, while downstairs on these two second horizons, we can see that we are a negative one. The most important diagram is over here given. So with the blue line is, you remember that planned time of arrival, which changes from day by day. And it could be like 25, then the couple of days, I mean, just tomorrow, like captain calls and picks up the phone and says, oh, I will be like 27 days and so on. However, over here, as you can see, what actually happened is the orange line. So it is like exactly what happened and how actually took that ship to get to a port from that point somewhere. It was somewhere in October, I don't know, 4th of October. While the model forecasts are given in the green. So at that moment, so neither the captain nor the first officer, no one from the ship actually knew that the ship is going to be delayed for almost 15 days. But the model over here actually predicted, and a couple of days ago, we really checked what's going on, and the ship really got to a harbor just a couple of days ago, so it's like 40 days really from this October. Of course, there are some differences. I mean, the model is good, but there are some things that are not that good. Firstly, so business being business, they want to have longer forecasting horizon. So, but that basically is not possible with the data we have currently. Secondly, in forecasting, it's not really okay if you if you want to given the daily data to provide the forecasts on, let's say, 26. 28, 37 days, a lot of things can happen in 37 days. So we said, okay, are you satisfied with 7? They said, oh, yes, we are. Okay, so if you are satisfied with 7, let's try it. But results were really good on the first 3, but awful on the last 4. So that's why we said, okay, let's do this with the 3 horizons. So you have 3 days of forecast. And over here, you just have a histograms. So the blue one, so this is basically just an error, right? So what the model actually forecasted on the first horizon minus what actually happened when the ship actually arrived. So as you can see on the first horizon, we are somewhere, so the distribution is really peaked. Which is like way better than the current solution which is in place. So we are in like -5 to 5 days. On the second horizon, a bit wider, but then again, it's better than the current situation. And on the first horizon, the same. So finally, as a final slide, so the things how we actually see the future. So the first one is we need to extend the data. Couple of things. So the first one probably is like we need to have the information regarding heavy traffic conditions, especially in the Suez Canal and in the weather forecast, for example, over here, and all these others. And I would just mention that currently we are having like snapshots on 24 hours. So if we just increase the frequency at least to 12 or 6 hours, that would be really cool. As a big company, so we can basically choose between AWS or Azure, but this shift to cloud is going to be really important. Why? Because when we scale this no server can do it. I mean, we just need the cloud for something like this. And me coming from a narrow network background, let's put it that way, I do believe that so these models based on trees, they are really good, but basically you get your features, you are the feature creator. While over here, if you get your networks to learn the features, plus you provide them with some features you actually create, you can have probably something better. But to do that, you need more data, of course. And finally, as Miodrag pointed out, there are a lot of talks going on with the providers, and they can even provide, for example, they can provide the data for a land transport and for a river transport. And that is going to be really, really interesting if you want to predict, for example, So you get to Hamburg, for example, and then from Hamburg, how do you get to Worms and how much that is going to take? So that is from our side. So if there are any questions, we'll be more than welcome to answer.
I'm sure that there'll be a lot of questions now
We'll see.
flashing your
Yes,
side.
We'll see.
Let's see.
So do we have at least one? That was a joke. Is anybody interested in?
No,
in
we are
some-
not twins. Yes, just answer in advance.
But we do look alike.
Yes.
Okay, we have one.
So one question regarding the training. So you mentioned already this disruption in the supply chain, right? For example, Suez Canal and also now the blockade in China. So during the COVID. So how do you make sure that your model is not influenced by this? You know, because it's something that hopefully doesn't come up in 2 months again. You know. So did you just take then this snapshot of data out to, or did you leave it in there? Now it affects actually your model, right? Because normally at the moment you should be faster than with this incidence.
Yeah. So what we do with the Suez Canal is we literally count how. So for example, given all this data we have, so at that moment we can see, for example, how many ships are in the channel in the last 24 hours, and then we can see, okay, so if there are like 100 ships, that is totally different than if there's like 500 ships. So the passage is going to be way slower. So that's how we solved it in Suez Channel. But it's a, let's say, crude statistical solution. Definitely you would need more data because these providers, they do not cover entire fleet of all ships traveling to Suez Channel. So the number of ships is way higher.
Do we maybe have another one? Oh, we do. Let me get your mic.
Regarding the time when you would need to retrain the model after 24 hours because you said you calculate the new features. So every day you retrain the model to get new predictions. Okay, thank you for clarifying.
Yes.
Okay, if this is it, maybe we can give a warm round of applause once again for
thank
Miodrag and
Thank
Ivan.
you very much. Thank you.
And